In this video, we're going to continue talking about section 1.3 and graphs of functions. This is part 2. As a warm-up, I'd like you to again practice another piecewise defined function. Make sure we understand the meaning. Once you've got that graphed, would you please identify the domain, the range, and then fully describe the function. When is it increasing? When is it decreasing? Have any constants? Anything else worth mentioning? All right, so I'm going to pause, or you need to pause the video and give that a try. Okay. So let's go ahead and see what we came up with as a graph. For all the x's less than -1 or +1, excuse me, I have a linear equation. And so just to remind myself, and this is not an asymptote, this is just sort of meant as a guide for me, that this is where the graph is going to go from a left side to a right side. And on the left side, it has a y-intercept of 3 and a slope of +2. So I'm going to go up 2 over 1, and it is or equal, so I'm going to put a dot. I'm not going to keep going because that moves into the wrong domain. So I'm going to go -2 and 1, -2, and our graph looks like this so far. And then I'll pick it up and do the other direction. And this time, since the y-intercept isn't part of the domain, it doesn't make a lot of sense for me to, to start up at 4. But what I could do is just kind of mentally do it, like 1, 2, 3, 4. So I'm starting right here. And then I'm doing what? I'm going down 1 over 1. And now I'm going to put an open circle here because the value of 1 is there. This is right up until then. And then I'll just keep going with a slope of 1. I'm sorry, -1. And so my graph looks like this. All right, what's the domain? Looks like all real numbers. Right, there's no breaks. The break here, there is a value right here, right? So everything has an answer. And so all the x's that are between -infinity and infinity. Range looks like we've got starting at the bottom, all the y's from -infinity, and then looks like we go all the way up to 1, 2, 3, 4, up to 5, including 5. And then we're going back down. The jump here doesn't matter because we have values right here. If there was no values there, then yes, we'd have this jump and we wouldn't include those y values. But those y values are still part of our graph. All right, so I'm going to say -infinity up to, what do we say, 5? And 5 is an answer. All right, when's it increasing? Increasing. From -infinity all the way to 1, not including 1 because 1's an individual point, not including -infinity. Let me use better language. All the x's so that's when it's increasing, and it's decreasing. When's it decreasing? From 1, all the x's, from 1 to infinity. It's never constant. Relative extrema. All right, so compared to points around it in the small neighborhood around it, I've got no relative extremes in here, right? Because we're just keeping it bigger. And then I get to this point right there. That point is bigger than all the points around it. And so I'm going to say that we have a relative maximum at the point 1, 5. Maximum of 5, 1's where it happened. Now, the question we need to ask ourselves is, do we have a relative maximum right here? And the answer is no. because there is no number that you can identify that is bigger, even if this side didn't exist, like even if the whole graph was just this part right here. There is no value for y that you can tell me is the biggest one there. Because if you told me 2.9, I could say, well, what about 2.999? Like we could keep going and play this game forever. So there is no value you can specifically identify that is bigger than the points around it. And so we have simply this one maximum up here, and we have no minimums because there's no spot where it's lower than all its friends. So that's all we've got. All right, let's keep going. All right, so today's lesson is going to focus mainly on symmetry, and it's going to be talking about even and odd functions. So I got some definitions for you here. Feel free to pause the video if you need to write these down. If a function has reflective symmetry over the y-axis, okay, then it is what's known as an even function. Okay, so this is even. So let's see what else we have here. So if it has reflective symmetry over the y-axis, and I don't know about the word "and" there, but what were we saying here? We're saying that if f of x, in other words, I plug in some x value, it's going to return a y value. So what must be true of f of negative x? So let's think about this. Again, one problem-solving strategy is to make the problem easier. It's very confusing language. So what this is saying is, if I, for example, if I figure out on some random function that f of 2 is 5, okay? If it has reflective symmetry over the y-axis, what has to be true when I plug in the opposite of 2, right? That's what this is saying. You plug in some x value and you get a y. Now it's saying what happens when you plug in the opposite of that x value. So in our case, that would be like plugging in negative 2. What would we have to get if it had reflective symmetry over the y-axis? Hopefully you can realize that the answer would be the same answer. And if we graph something, right, sketch a graph of such a function, one example would be something like a parabola. So if I look at the parent function of a parabola, we know it looks like this. So it is reflective over the y-axis, meaning when I plug in a number over here, some x value, I'm going to get this y value. So I plug in this x, and I get the point x, y. So what happens when I plug in the opposite of x? So now I'm over here. Well, I should have the same y value. Okay, hopefully that kind of makes sense. So even functions are things like parabolas. Right? If you want to think even function, your first go-to thought, absolute value graph, parabola, something like that. Okay. Next definition, and this would be for an odd function. An odd function is one that it is not reflective over the x-axis. That's not the thing. And I want you to pause for a minute and think about why would that not be the thing? An odd function would not be talking about reflecting over the x-axis, because then we'd have something that maybe looked like this, and if reflected over the x-axis, it would look like this, right? And so now the graph is reflective over the x-axis, but what is that? Not a function. So that can't be what an odd function is. Is it a thing? Is it symmetric? Yes, it's something we could talk about, but it's not what is known as an odd function. So an odd function is one that has 180-degree rotational symmetry about the origin. So think real quick about what kind of a function that might be. And as you're thinking about it, let's read the next sentence. If we plug in a value of x and we get a y value, what must be true about when we plug in the opposite of x? Okay. So a function that has got rotational symmetry could be as simple as y equals x, but let's do one that has a little more excitement to it, and that would be our friend the cubic graph. If I look at y equals x cubed, that graph is sort of like a parabola going this way, but then the other side of the parabola shape is going down. So what is it talking about? If I plug in an x value, so let's pick any x value, let's say here, I get this y value. What happens when I plug in the opposite of this x value? Well, that's going to put me on the other side, right? Not to scale. And then what is the answer going to be right here? Well, if it's symmetric, then the distance here and the distance here should be the same. There just happen to be opposites. Same height as this one, just in the negative instead. So that is what an odd function is. The line y equals x would also be odd, right? If I plug in this x value, I get this y value. If I plug in the opposite of this x value, I get the opposite of that y value. All right. Hopefully that makes some sense, and everything I do next won't undo what you hopefully understand. All right. So to complete your notes, make sure you've got a nice picture here. Let's do some even functions. So even function means reflective across the y-axis. So let's give ourselves a quick reminder of that family, and that would be let's do absolute value this time. Okay. Odd function. Let's go ahead and just throw our cubic function back in, or we could even do our cube root function, right? Cube root function looks like this and like this. Okay, what is the algebraic test? And the answer lies in what we just did. We know that we have a function f of x. What do we get? So this is the output, right? Think of this f of x as the output when we plug in an x. So we have an output when we plug in x. What has to be true is that it's going to be equal to the output when we plug in negative x. F of x has to equal f of negative x. And what is the algebraic test for an odd function? F of x compared to f of negative x. And the answer would be that f of x has to equal, and let's say we can put the negative on either one of these, but basically the opposite. I may change my mind in a minute, but let's stick the negative right here. So the output when you plug in x should be the opposite of the output when you plug in negative x. And honestly, I'm thinking I like it better another way. We're gonna do a little math here, and we'll find out in just a minute. Another way of saying the same thing would be the opposite of f of x, right? The opposite of the output at x is equal to what we get when we plug in negative x. So either of those work. There is a more standard way of doing it, and honestly, just doing it cold here, I can't really get a feel for it. So we're going to take a look in a minute and see what we're going to get here. Let me scroll down and see what's next. All right, let's do an example of each. Okay, so let's take a look at one that we know. I'm going to do x squared because that'll be easier to do the math on. So we are starting with f of x equals x squared. So what I want to do now, okay, I'm just going to, there's where we're starting. I want to figure out what is f of negative x, and I'm going to show my work. So I'm literally going to just do exactly what this says, which says go to the function f and replace the x with negative x. So here's the function f, and I'm going to replace the x with negative x, which we know when we square this, a negative squared becomes a positive, and x squared becomes x squared. We get x squared. So I have the statement that says f of negative x equals x squared. But what do we know x squared is equal to? It's equal to f of x. So I can substitute and replace it, and I get the statement that f of negative x equals f of x, which is what we said had to be true for it to be an even function. All right. I think it's going to be this test over here, by the way. All right, let's take a look at now another function we know. Let's do x cubed. We know that it's odd. Now let's show it algebraically. Okay, so there's the function. Now let's do the math. So to figure out what's going on, determine if it's even or odd, or maybe it's neither, we're going to plug in negative x. So I'm going to take the function f. Oops, let me get rid of y there. I'm going to plug in negative x instead, which gives me negative x cubed. I'm going to simplify, and I get a negative cubed, right, is negative, and then x cubed is x cubed. But what is x cubed? X cubed is f of x. So I get negative, and then I'm going to replace x cubed with what it equals, which is f of x. And I get this statement right here. The answer to when you get plug in negative x is equal to the opposite of the answer when you plug in x. All right, so we're going to use this as our test over here. Let me get rid of that. Don't get too hung up on this. This is like sort of the advanced part of the math. The basic part of even and odd is understanding the structure. Symmetry across the y-axis, symmetry with respect to the origin. All right, so your job is to see if you can prove whether the next 5 are even, odd, or neither. See if you can figure it out, and then let's check back in and see how you did. Example number 2. Now we're just going to run our test to see if it's even, odd, or neither. And honestly, the absolute value one's a little bit confusing. So let's start on B and C, and let's come back to A. So let's start with B. And we're going to say, so the test is the same. We know what g of x is. The question is, what is g of negative x? And so what does that tell us to do? It says go find the function g, here it is, and replace x with negative x. So I get negative x. All right. And then if I stop and look at this, well, this is like a negative 1 times x, right? But what do we know x itself is equal to? We know it's equal to g of x. So this is the same as replacing x with g of x. Negative x is the same as negative g of x. Here's x. You can substitute in g of x for it. So I got negative g of x, which leaves us with this statement. When we plug in negative x, we get the opposite answer to what we get when we plug in positive x. And that is the definition of an odd function. So this is odd. All right, let's move on. Let's try part C. We know what f of x is. What can we do to negative x? Can we manipulate it in any way that's helpful? So let's rewrite it. 5 minus negative x to the 4th power. All right, what is negative to the 4th power? It's a positive. So this simply becomes 5 minus x to the 4th. Well, 5 minus x to the 4th is just what f of x is. So I can substitute and replace that with f of x, which gives me the statement f of negative x equals f of x, which is our definition of even. And if we graph this thing, we know that it's even because it's a parabola. It's upside down that's been shifted up 5. So this is just a parabola that looks like this, which is definitely going to be even. All right, let's try another one. Here we go. It's definitely not going to be an even function. So the question is it odd or is it neither? So let's find out. G of negative x. I'm going to plug in negative x. A negative to the 5th power is negative. So I can rewrite this as a negative x minus 2x to the 5th. All right, so I look up here and it's not the same. And if I factor out a negative 1, I get x plus 2x to the 5th power, which, unless I've made my math wrong, x plus 2x to the 5th is g of x, so I can replace all of that, and I get the statement equals negative, and all of that is g of x. So I get g of negative x equals the opposite of g of x. So this one would appear to be odd. Let's check it on our calculator, shall we? So let's go to graph, and I'm going to do x plus 2x to the 5th. And I'm expecting to see something that kind of looks like a cubic function, going up or going down on the left and up on the right. Let me do a zoom 6, and there we go. Yep, so makes sense. All right, next one. Do our test. 3 minus negative x to the 5th gives me 3. A negative to the 5th power is negative, and subtracting makes plus x to the 5th. All right, so here's my problem right here. This says 3 minus x to the 5th. This says 3 plus x to the 5th. If I try to factor something out to try to get this x to the 5th to a negative, I could try that, but then that's going to also factor out here, and I'll get negative 3 minus x to the 5th, which is not what this says. So h of negative x doesn't equal h of x. I can't just substitute and say this is h of x, because it's not. So it's not even. And I can't say it's the opposite, right? Because I can't replace this once I factored out a negative. I can't replace that with h of x. And so this one is neither. All right, I think that's probably enough of this. We'll just go ahead and skip example A and maybe talk about it in class. But that is even and odd. Don't get hung up in the algebra if I'm kind of confused here. Don't give up on it, but don't think that you're a failure if it's confusing for you. We haven't asked you to think like this in math for a while, and so this could be a little challenging to start. As long as you understand that an even function is symmetric across the y-axis and odd is rotational, then that's most of what you need to know. All right, we'll see you in class.